Right, this is Nicola. We're going to have a look at calculating a type 2 error. Now, on the number 15, hypothesis testing, I've put in a video called Super Easy Tutorial on the probability of a type 2 error, which it is, beautifully done. And this is the question that he does. My Australian, the one that did the probability introduction of hypothesis testing with Sam, his dodgy mate, if you remember. So anyway, this is the question. I need to have a look at it. Peter claims that the average score for a final exam is less than 60%. You gather 51 test papers and calculate the average sample to be 57 and the population standard deviation to be 12. Suppose the lecturer, Professor Bigwig, knows that the true average of the exam is 58. Calculate the type 2 error and test Peter's claim at the 1% significant level. Now, what he's done is absolutely fine, other than that he's used the Z-score, which is just, you don't need to do that anymore. So if you look at his video and get the explanation, but the easiest thing to do is, like he said, consider the original, oh, it's not going to stay still, consider the original question. We reckon that the mean is 60, that's what they've told us to start off with. We know we've got to use standard error because we've got a sample mean, so the mean is 60, the standard deviation is 12, and its standard area, which is 51, so 1 over, over root 51 squared. We always have to show the variance if you remember, so be careful about that. So that's what we've got. We know he wants to do it at a 1% significance level, and I think we're looking at the lower end because he's saying knows the charge is less, so he thinks it's well, we know he's less. Is less than. So there we are. So we are looking for the lower end if we'd actually done the test. So this would be your 1%. This would be where you would reject H0. So if we need to find this value, easiest way of finding that value, and I hope you're remembering this, is to go to Stats, Distribution, Normal, Inverse Normal. We're on the left-hand side. It's 1%, 0.01. We have a standard deviation of 12 divided by root 51, and our mean at the moment is 60 because that's what we believe to be true. So if we were true on that, where's it gone? We would reject at 56.0909537. I'm going to keep all the values at the moment so that I don't get any error. So if that's the case, then we would accept H0 in this area. And then we know Mr. Bigwig's told us that the true value is that. So what we want to know is the probability of a type 2 error. A type 2 error is accepting H0 given that we shouldn't have, given that H0 is wrong. So given that mu is now 58. So accepting H0 means we want, I'm going to change it to y, is greater than that value, 56.0909537. Oh, given that we've got a new mu of 58. Well, that's easy enough. We just stick it in our calculator. We now just need to find out distribution, normal, cumulative. We want greater than that. So we want 56.0909537 all the way up to 99999. We have, should be the same, but I'll put it back in again. So 12 divided by root 51 because it's standard error. Brilliant. But our new mean is 58. And I've got 0.872 04469, so approximately equal to 0.8720. I got 8. If you do what he did in the video and use a 56, not do that, 56.09, then you get exactly, given that mu is 58, you get exactly his answer, 21634. Obviously, I think we've done it better by being more exact at this point, because we have the calculators we can do so, but this means that you don't have to do any Z-score at all. You just do inverse normal to find your critical value, draw a little sketch. Wherever you reject H0, you don't want that side, you want where you accept it, and you want where you accept it with the true new mean. That's the probability you're looking for, where you accept it with now the mean you know is true, not the mean you know is wrong. So you accepted it when you shouldn't have. and that's what we're looking for. Okay, hopefully that helps explain, but watch the super easy tutorial that I've put in under section 15, that is hypothesis testing, significance testing, confidence intervals and power, to help you check through that. So it's Australian, and check him out.